Welcome back to the CCA-F learning series. In Concept 1, we answered what makes a system agentic. In Concept 2, we answered where the human fits in. Now the question becomes, how do you communicate with the model precisely enough to get reliable, parsable results every time? That is Concept 3, prompt engineering and structured output. Let's go! If Claude understands natural language, and it clearly does, why does prompting require a discipline of its own? Why do engineers spend weeks refining system prompts for a model that could answer this question in plain English? Because understanding language and reliably producing what you need are two completely different problems. And that difference is what this concept is about. Here is the mental model that makes everything else make sense. An LLM generates the statistically most likely next token, given everything that came before it. Your prompt does not instruct the model. It shapes the probability distribution of what comes next. Every word you add either narrows or widens that distribution. A vague prompt creates a flat distribution. Many outputs are equally likely. The model picks one, and it may not be the one you needed. A precise prompt creates a peaked distribution. The output you need becomes overwhelmingly more probable than any alternative. Prompt engineering is the discipline of reducing output entropy by increasing input precision. Not magic, not art, applied probability. Every effective system prompt has 4 components. Role. You tell the model what it is. You are a customer support classifier for an e-commerce platform. Context. You tell the model what world it operates in. Tickets come from customers who have placed orders. Tone ranges from polite to frustrated. Constraints. You tell the model what it must not do. Only classify into billing, shipping, product, or account. Do not add categories. Do not explain your reasoning. Format. You tell the model exactly what the output must look like. Always respond with valid JSON only. No preamble, no text outside the JSON. Role narrows who you are. Context narrows the world. Constraints narrow what to produce. Format narrows how. All 4. Every time. Here is the second major tool. Few-shot prompting. Show, don't tell. Instead of describing the pattern you want, you show the model 2 or 3 concrete input-output pairs. Each example collapses the probability space towards the exact pattern you have demonstrated. Without examples, the model's output varies. Sometimes narrative, sometimes a list, sometimes JSON, sometimes all 3. Consistent structure in, inconsistent structure out. With 2 well-chosen examples, the model locks onto the pattern. Output becomes consistent JSON on every call. One well-chosen example often outperforms 3 paragraphs of instruction. Examples ground the distribution in demonstrated behavior, not described behavior. That distinction is everything. Let's make this concrete. An AI agent reads incoming customer support tickets and must classify each one for the downstream system. Input, unstructured customer text. Required output, structured JSON the routing system can parse and act on every single time without variation. The downstream system is code. It cannot handle narrative text, varying field names, or unexpected structure. Reliability is not a preference here. It is the product requirement. Bare prompt. No system prompt, no schema. We send, classify this support ticket, and the same ticket 3 times. Run 1 returns narrative text. The model explains its reasoning in full sentences with no consistent structure. Run 2 returns a pipe-separated list, category, priority, action, but in its own format with its own field names. Run 3 returns JSON, but with different keys than Run 2, and a different structure entirely. The model understood the request every time. The routing system crashes on all 3. Understanding the intent and producing a reliable contract are not the same thing. Now we add the system prompt. The role? You are a customer support classifier. The format instruction. Respond only with valid JSON matching this exact schema, no other text. Then the schema itself. 4 fields with their allowed values. Category, billing, shipping, product, or account. Priority, low, medium, high, or critical. Sentiment, positive, neutral, frustrated, or angry. Action, auto-resolve, queue, escalate, or urgent escalate. That is the complete system prompt. We run the same ticket 3 times. Every run returns the same 4 fields, the same field names, values from the allowed set only. No preamble, no explanation. Valid JSON. The routing system parses it without error. Every run. That is what a JSON schema does inside a system prompt. It does not describe the output format. It constrains the output space. We now add 2 few-shot examples to the classifier prompt. Example 1. Input. My last 3 orders all arrived damaged. Output, category product, priority critical, sentiment angry, action urgent escalate. Example 2. Input. Quick question. Can I change my shipping address? Output, category shipping, priority low, sentiment positive, action auto-resolve. 2 examples. That is the entire edition. Without examples, schema adherence across varied tickets sits around 70%. Ambiguous cases drift. The model invents priorities, adds unsupported field values, occasionally adds explanatory text. With 2 examples, adherence climbs to around 97%. The examples do not teach the model new information. They demonstrate the exact pattern, including edge cases, so the probability distribution peaks at correct behavior rather than averaging across many possible behaviors. Even the best designed prompt fails sometimes. Edge cases, unusual ticket phrasing, or model variance at the probability boundary can still produce malformed JSON. The routing system will still crash. The answer is not to assume it won't happen. The answer is to design the recovery. Step 1. Attempt to parse the model's response as JSON. Step 2. If valid, proceed to the routing system. Step 3. If invalid, send a correction prompt. Your response was not valid JSON. The error was bracket not closed. Please respond again with only valid JSON matching the schema. Step 4. If the retry also fails, escalate. That escalation is a human-in-the-loop checkpoint, triggered not by business logic, but by structured output failure. The retry loop is the connection point between this concept and concept 2. Prompt engineering, structured output, and HITL design are not 3 separate tools. They are one system.
The clean definition. Prompt engineering is the discipline of reducing output entropy by increasing input precision. 3 tools implemented. The system prompt defines role, context, constraints, and format. It narrows the probability space from the start. Few-shot examples. Ground the distribution in demonstrated behavior, more powerful than description alone. The validation retry loop catches edge case failures and recovers, or escalates to human review when recovery is exhausted. 3 tools, 1 discipline, 1 goal. Reliable output. Every time. In Concept 4, we move into tool design and MCP integration. This is where agents stop reasoning about the world and start acting in it, using tools to search, write, execute, and communicate across real systems. If this video helped, please like it. Subscribe to BornToSkill on YouTube at born_2skill. X and Instagram, same handle, born_2skill. See you in Concept 4.